was just fixing my good old handy-dandy Patriot sign. Love that team. Go Tommy. Someday I'm going to have a grandchild named Brady, right? Kids? Okay, today we are doing elimination using addition and subtraction. So we're still dealing with systems. You've learned that in systems, you can solve systems by, what's the first way we learned? We learned graphing. Okay. In graphing, you have to graph both lines and see where they cross, or see if they're the same line, or see if they're parallel. Then we learned substitution, okay? And in substitution, if you had it into y equals or x equals, you can just really easily take y equals and x equals, whatever that is, and pop it into the other equation and find what your answer is. Today we're going to be using elimination. You guys are going to like this one. This is my favorite because it's the easiest, okay? So here's what you do. You basically line up your x's, your y's, and your numbers. So notice I have the x's, and this problem was given to us very nicely. We have x's lined up, we have y's lined up, and we have numbers lined up. Guess what? You get to basically make this an addition sign, okay? If I can cancel anything out, that's my goal. So here I get to cancel out my y's because a positive 6 and a negative 6, that would actually cancel out. And I just add 4 plus 3 is 7x equals 32 plus 3 is 35. Look at how nice this is, guys. X equals 5. Bam. I'm already done with that one. Take the x equals 5, go back and pop it into either equation. I don't care which one you choose. I'll just choose the first one. Instead of writing x, I'm going to write the answer that I just found because my goal is to find y. When x equals 5, let's see what y equals. 6y equals 32. Subtract 20 on both sides. And I get 6y equals 12. And then divide by 6. My answer is y equals 2. A lot easier than graphing, to be honest with you, and easier than substitution as well. My answer is 5, 2. That means if I graphed this line and I graphed that line, they would cross at the point, those lines at 1, 2, 3, 4, 5, 1, 2, bam, that's where these two lines cross. And that's what we're always trying to figure out with systems. Where do they meet? Where do they intersect? Where, you know, whatever. Over here, okay, I've got my x's, my y's, and my numbers lined up. If they are already opposite signs, I get to just do beautiful things like this. Negative 4x and positive 4x cancels. My goal is always to cancel either the x's or the y's. In this problem, I cancel the x's. So now I have a negative 5 and a positive 3. That becomes negative 2y equals 5 minus 3 is 2. So I'm just going to divide by negative 2. And now I get y equals negative 1. That's half of my answer. I'm almost done. Go back in and plug in negative 1 for either problem. I'll do the first one. Negative 4x plus 3 times what I got for y equals negative 3. Negative 4x minus 3, because 3 times negative 1 is negative 3, equals negative 3. Add 3 to both sides. I get negative 4x equals 0. Divide by negative 4. 0 divided by any number is just 0. So these two lines cross at the point 0, negative 1. I'm done. Okay, I could put 0, negative 1 in both of these equations and it will work out. I have one more example for you. Whoops, and I'm going to trip. Okay, I have my 4y and my 3x and my 4y. That's not going to work out. I have to rearrange my problem. So I will write 4y plus 3x equals 22. And I'm just going to rearrange the second one so I can get the 4y underneath. And then the positive 3x and the 14. So all I did was take these two things, swap places. 4y minus 4y cancels. Oops, I wrote 36. Should be 3x. 3x and 3x is 6x. 4 and 2 is 6. 2 and 1 is 3. 6x equals 36. I will divide both sides by 6. X equals 6. Okay, once I get x equals 6, I'll just use the second one this time. I'm going to plug in 6 for x. So this is just substitution, plugging that in. 3 times 6 is 18, minus 4y equals 14. Subtract 18 from both sides. I get negative 4y equals negative 4. Divide by negative 4 on both sides. Negative 4 divided by negative 4 is positive 1. These two graphs, this system crosses at the point 6, 1. That's my answer. That's my ordered pair. All right, we'll see you in class today. Bye.